Similarly, if computer 2 needs to kind of communicate with 1 or 3, they use the same connection, the same wire that is going back and forth to kind of communicate with each other. So one of the pros of this network is that it's very kind of simple. It's just like you connect a Ethernet cable, you from start to bottom, and start tapping different devices in that wire, Ethernet wire. So the only cons of this is that here we need to kind of decide somehow that, okay, if one is kind of, let's say if one is kind of trying to send data to the 3, so the 2 should avoid sending data to any other devices, for example. Otherwise, what will happen is that if one sends the data to 3 and at the same time 2 sends the data to let's say 1, so there will be kind of a collision of the packet, and the problem will be there is that neither 2 will be able to reach out to the 1, nor 1 will be able to reach out to 3, because the packets will collide, and due to that noise, the information that is contained in the packet won't be able to kind of correctly reach to between the devices. So over here, one needs to kind of see if there is no kind of communication happening over in the wire, then only kind of the communication, a computer starts doing a communication to any of the devices, okay, back and forth. So that's kind of a normal what topology means. Topology means the architecture of the network which has been kind of set up, and the bus topology is the simplest one. Okay, so now if we kind of talk about the LAN architectures, we can not just like have a LAN topology, we can also have a star topology. So this is where like a star topology is. So here thing is that over here till this part is something which is like a star topology, and here let's say this part is the bus topology. So in a star topology, it can either be a router, okay, or in basic terms, it also can be an hub. So hub is nothing but it is just a kind of a physical repeater, and what it does is like if this computer wants to communicate with this computer, it just kind of basically sends the data via, the data will basically be sent via hub to over here, and at the same time hub will also allow kind of, let's say, this computer to kind of communicate with this computer. So all the data will be kind of going back and forth between the hub. And one of the con of this is like if it is not a router but a hub, so one of the con is that if the hub is like not smart, so again it will be one of the issue phase will be the collision. So if computer C is trying to communicate with computer, let's say D over here, and at the same time P is trying to communicate with D, thus again the packets will kind of collide, and the information that is present in the packet will be kind of lost. Okay, so that's kind of how the normal star topology looks like, and how the bus topology looks like. Okay, and we can kind of also have kind of, let's say, the other topology can be extended star topology. Okay, so it can be like extended star topology, and what basically happens here is that, let's say, one of the easy diagram to understand is that, let's say there is a hub. Okay, let's say there is a hub, and there are like computers over here. Okay, let's say there are computers over here, and what would happen is that this small network over here, will have its own kind of, let's say, a hub, and let's say this and this computers are connected to each other, and then this hub is connected to the central hub, and that will be the same architecture, let's say, over here. So there's a hub, and the computers are connected to this hub, and then the local hub over here is connected to the central hub. So this is how the extended star topology will look like. So so rather than using a simple diagram, what we do is like there's a lot more hubs or routers, and then each star is kind of connected to other star via a kind of a central hub. So that's what is external kind of a extended star topology would look like. And one of the kind of cons of this is like if this central hub gets down, so no other local star topology will be kind of able to kind of communicate with each other. So there will be a need of, let's say, another backup backup hub. So or router, what to kind of have a better external topology. And what will happen is that these two hubs, let's say, communicate with each other. Okay, they kind of check the health of each other, and if, let's say, one is down, automatically the traffic which was kind of being handled by this hub is kind of now handled by the hub which is kind of healthy. Okay, and that's where kind of those are some things like we can kind of implement in a star topology and make the network kind of still going on. Okay, so that's what a kind of a normal star topology, normal extended star topology will look like. Okay, so I hope like most of you guys will already have this kind of basic knowledge. But even though, like, if you guys have any questions, feel free to interrupt me. And now I'll be a little bit speed up because these are some of the concepts which are a little bit basics one, okay, but just covering out so that everyone is on the same page. Okay, now let's go to the first thing, which is kind of the OSI layer. Okay, and what is so OSI layer, and what is like why it is kind of needed for us to kind of understand whenever we deal with any network fundamentals. One of the most, this is one of the most important thing to kind of discuss about, which is OSI layer. Okay, so what is OSI layer? So let's kind of first kind of quickly draw the layers. Okay, so in the OSI layer there are actually 7 layers. Okay, so one of the layer, the first layer in the OSI layer is like physical layer. Okay, on top of that there is actually another layer, which is, let's say, data link layer. Okay, then there is on top of that, let's say, there is the third layer is network layer, which is also called as L3. Okay, then there is transport layer, and then the next one is session layer, and the last L6, not the last but the second last, which is also called as presentation layer, and the last layer which we normally interact with as a human, which make more sense to us, which is application layer. Okay, so OSI is nothing but kind of a understand it kind of it is made of kind of 7 layers, and 7 layers, and it is something like which help us to kind of understand how the one computer connect with other computer. And to understand that in a better way, what we can do is like we can talk about the OSI layer, which will help us to understand how two computers or one or more computers talk with each other over the wire or over the wireless architecture. Okay, so why we always kind of go through the OSI layer whenever we start with network fundamentals? Because it helps us kind of let's say there is one computer over here, and there is another computer, let's say, over here. Okay, so let's say it's C2, and let's say it's C1, and let's say there is a router over here. Okay, let's say both of this are somehow connected, let's say via wireless. Okay, so now to understand how this C1 communicates with this C2, it's always better to kind of understand it via OSI layer, which is like we separate the network in 7 virtual layers, starting with physical, and that ends with kind of application. And the reason for kind of understanding the OSI layer is kind of it actually simplifies the teaching and learning, and how the network actually evolved going forward from physical to application layer in the past. Okay, so now let's start with kind of understanding all the layers in kind of in as much as layman's term as possible, and kind of feel free to kind of interrupt whenever you feel you have any kind of queries. Okay, so OSI layer is the full form of OSI layer is Open System Interconnection. Okay, so Open System Interconnection model is actually a concept